In today's session, so on these topics, we are going to discuss reciprocal cone, right circular cone, and finding vertex of a cone. I think remaining concepts we have done in the previous class. And we are going to take some problems also based on the previous session that we discussed. So please take a note of these things. So the first problem is the plane x by a plus y by b plus z by c equal to 1 meets the axis in ABC. Prove that the equation to cone generated by lines drawn from origin to meet the circle ABC is so this is our problem. So please note down carefully. So here, if you observe that we have a plane equation which intersects the coordinate axis in the points ABC. The solution is also given in the problem that if you calculate the equation of the cone, it is nothing but the big equation which is given in this problem. As we know that whenever we draw a cone equation, obviously it should have a vertex and the generator of the cone touches a base curve. So in the problem, it is observed that the base curve is nothing but this circle. Now tell me how a circle forms. As per the previous topics in the discussion of solid geometry, how do we get a circle? As per the previous topics concerned, so plane and sphere as and when intersects, you will get a circle. So here also we have to assume that the base curve is nothing but the intersection of a sphere and a plane. From the very problem, if you take that this is the given plane meeting the coordinate axis at the points ABC, obviously the points are nothing but A00, 0B0 and 00C. These are nothing but the intercepts ABC. And if you want to consider the sphere, I will consider the sphere as passing through OABC, because in order to determine a sphere equation, we should have 4 points. The 3 points are taken as it is, and I have taken origin as an extra. So using the 4 points, the sphere equation will come as x square plus y square plus z square minus ax minus by minus cz equal to 0. This thing we have already done in the spheres part. Now what happens? This is the sphere and this is the plane. These two will intersect, will get a circle, and the 3 points on the circle are nothing but the points ABC. Clear? Is it fine to all? Yes or no? Now, please understand that we are finding the equation of a cone from origin. In other words, the vertex of the cone is nothing but origin. So, as we have studied the cone properties, whenever you find a cone equation with vertex at origin, always you will get a homogeneous equation in the respective variables, either 3 variables or 4 variables, whatever may be the case. So whenever the vertex is origin, always we get a homogeneous equation that will represent a cone. Clear? So if I find a homogeneous equation passing through origin, that is nothing but the required cone equation. Now, from this sphere equation, if I make this as homogeneous, then I will get the required solution. That is the main idea behind it. So, if I am able to make it as homogeneous, then obviously it will give the required cone equation. So, how I am making it as? This will be written as so in place of 1, I will substitute the respective equation value. So which gives that now if you multiply all these values, x square, y square, z square gets cancelled and you will get the solution of the problem. So this is nothing but required solution. So it is a very simple problem. If you consider the writing part, we just mentioned 3 lines. First one, we consider the sphere equation passing through the points OABC, and we mentioned that the sphere and given plane both will intersect, which results a circle having the 3 points ABC. Second point is, since we are calculating the cone equation with vertex at origin, so every homogeneous equation will give the required solution. And third step is, if we make this as homogeneous, which gives the required result. So in this place, by substituting the respective value, you will get the homogeneous equation, which is nothing but our solution. Okay? Any doubts? So always a homogeneous equation in n variables represents a cone with vertex at origin. Please understand. That is why we are making it as homogeneous. Homogeneous is nothing but each term having equal degree. Fine. Any other doubts? Right? Then I will take the next question. So another technique of finding a cone equation is nothing but if you make a given equation as homogeneous, that always give the required cone equation with vertex at origin. That was the idea here in solving the problem. So the next problem is, show that the plane ax plus by plus cz equal to 0 cuts the cone Which problem can you tell? On what model? So vertex and the base curve you are saying, right? The 0.543 and guiding curve is 3x square plus 2y square equal to 6 and y plus z equal to 0. Is everyone having the same problem with that? You mean all the values are different or some values are getting different? All the values or some values in the coefficients? Right, I will post the solution separately then, right? But with regard to the problem approach, do you have any other questions in solving that? Right, then it is okay. Now let us consider this problem. We have to show that the plane ax plus by plus cz equal to 0 cuts the cone yz plus zx plus xy equal to 0 in perpendicular lines if this condition is satisfied. So it is the other way around, asking that if plane cuts the cone giving two lines, and if the two lines are perpendicular, then you will get this condition. As we have studied that whenever a plane passes through the vertex of the cone, always we will get two lines. The two lines may be of any kind. They may be perpendicular, they may be very close to each other, they may have an acute angle, etc., etc. Whatever the case we consider, if the two lines are at right angles, then this condition must be satisfied. That was the question tag here. Is it clear? Say. So the approach of the problem is very similar. We need to know how to calculate the lines when a plane cuts the cone. And if you observe that as the plane passes through origin, and from the very cone equation you say that the vertex of the cone is nothing but origin. So you consider the generator equation as x by L is equal to y by m equal to z by n. This is nothing but the generator equation, also nothing but the lines of intersection, because the generator is also nothing but the line of intersection as and when the plane passes through the vertex of the cone. Proceeding as it is, applying the normal condition and DCs of the line satisfy the cone equation, you have AL plus Bm plus Cn equal to 0. This is one equation, and the other one is Mn plus Ln plus Lm equal to 0. I think you get the approach, how these equations came. Clear? Or you have a doubt? Yes or no? Because the normal of the plane is perpendicular to the line, so we will apply perpendicularity condition for the plane DRs and the line DCs. I mean the DRs. Right. So from this we have to eliminate one parameter. So if you observe that from this very equation, n is equal to minus of AL plus BM by C. Please understand that we can eliminate any one parameter, either L or M or N. Here I have taken N. Now substituting N value in the respective cone equation, you have M into minus AL plus BM by C plus L into minus of AL plus BM by C plus LM equal to 0. So you simply calculate the LCM and simplify it. Because I mean the DCs of the generator will satisfy the cone equation, isn't it? That's why I have substituted Lmn in the cone equation. So you have Mn plus Ln plus Lm equal to 0, isn't it? That's why I have written. Fine. Okay. Now if you simplify the equation, you will get it as AL square plus A plus B minus C of Lm plus Bm square equal to 0. So on simplifying this equation, you will get this one. I think simplification that you can do on your own. I hope so. Now what happens? Since I want to prove a condition here, I am going to make it as quadratic. So dividing with m square, we will have A into L by m whole square plus A plus B minus C into L by m plus B equal to 0. So this is a quadratic equation with the variable L by m. Since every quadratic equation has two roots, it will possess two roots. So we say that the first one is L1 by m1 and the second one is L2 by m2. As you have studied the sum of the roots and the product of the roots formula, applying here, for the product of the roots, if you consider L1 by m1 dot L2 by m2 is nothing but B by A. Agree? Now, which gives that L1 L2 by B is equal to M1 M2 by A. Accepted? Now, actually what happened, we are doing the usual procedure that I have taken the generator equation, I have eliminated one parameter, substituting in the cone equation, I have taken a quadratic one. So in the beginning, I have eliminated n, so I got the equation which is quadratic in the variables L and M. Instead of that, if I have eliminated m here, I will get an equation in L and N. Accepted? You can eliminate any parameter in the beginning, right? Here I have done with n. So at this position, from this equation, if you have taken that m is equal to minus of al plus cn by b, then substituting m value here, you will get a quadratic equation in the variable n by n. Accepted? So that you can do with any variable. So by symmetry on comparison, you will get that L1 L2 by B is equal to M1 M2 by A is equal to N1 N2 by C. This is on comparison. Fine. So from this very equation, you can also say that L1 L2 by 1 by A is equal to M1 M2 by 1 by B. That is also correct. So you can write the symmetry in the other way also as L1 L2 by 1 by A is equal to M1 M2 by 1 by B is equal to N1 N2 by 1 by C. It is also correct. Agreed all? By taking cross multiplication here, say. Now the question is given that the two lines, what you are going to calculate, the intersection lines, if they are perpendicular, you have to show some condition. So if you say that L1, M1, N1 are DCs of one line and L2, M2, N2 are DCs of the other line, then as per perpendicularity condition, you have L1, L2 plus M1, M2 plus N1, N2 equal to 0. This is nothing but the perpendicularity condition. So since the values are proportional, from this value you can say that 1 by A plus 1 by B plus 1 by C equal to 0. So this is our answer. You take a note of that. So this problem is also very similar to the same problem what I have taken now. Show that the condition such that the plane ux plus vy plus wz equal to 0 may cut the cone sorry. This is also a very similar problem to the previous one. So we have to show that if the plane ux plus vy plus wz equal to 0 will cut the cone ax square plus by square plus cz square equal to 0 in two perpendicular generators, then you will get such type of condition. B plus C into U square plus C plus A into V square plus A plus B into W square equal to 0. So let us do the same procedure as per the previous one. So let us take that x by L is equal to y by M is equal to z by N is the generator and also the line of intersection. for the cone. So as usual, we can apply the perpendicularity condition for the plane drs, and the generator element values will satisfy the cone equation. So you can say that ul plus vm plus wn equal to 0. That is one. And the other one is al square plus bm square plus cn square equal to 0. So from the very plain equation, you can eliminate any parameter. So if you eliminate the parameter n, then you have n is equal to minus of ul plus vm by w. Substituting the value in this equation, so you have al square plus bm square plus c into ul plus vm by w whole square equal to 0. So you can simplify the part. So on simplifying, you will get that aw square plus cu square of L square again. If you make this equation as a quadratic equation by dividing with m square, you have right. Now, since this is a quadratic equation, it will contain two roots. Let us take one root as L1 by M1, another root as L2 by M2. Applying the product of the roots, you have L1 L2 by M1 M2 is nothing but the constant by x square coefficient. We have written like that. Again, you can write it as so. As per our discussion, again, apart from eliminating the parameter n, if you eliminate any other parameter, you can have similar kind of equation with other terms, m, n or l, n. Hence, by symmetry, you can say that n1 by n1 n2 whole divided by a v square plus b u square. This is the value. So by symmetry, I am writing the last one. Please understand. As we have BC, AC, so you will be having here AB. The remaining procedure is very common. Since it intersects in perpendicular generators, you have the condition that L1 L2 plus M1 M2 plus N1 N2 equal to 0. So applying for the values in the denominator by taking u square, v square and w square as common, you will get this result. So as you have that bw square plus cv square plus aw square plus cu square plus av square plus bu square is equal to 0. So taking u square, v square, w square as common, you will have the respective result. So this is nothing but the solution of the problem. The approach is very similar to the previous one, what we did. The only thing is plane equation and cone equation were just changed, that's all. So that the result varies. Is it fine? Then I want to discuss the other model. I think it will be av square plus bu square, because if you common v square, you will get a plus c. Please check. As per the answer, I have written that. As per the answer, I have written that. Yes. I can say one more thing. So if you want to get the correct idea, so earlier you have done the problem by eliminating the parameter n. Now what happens? You have to do two things here. So at the substitution part, you can perform two things. One part you perform that eliminating n. In the other part you perform that eliminating L. So from that L is nothing but minus of Vm plus Wn by U. So here you will get a quadratic equation like this. Here also you will get a quadratic equation like this. If you sync these two things, you will get the exact symmetry here. That you can perform. But it is a little bit lengthy. You have to increase a half-page answer. So to avoid that, straight away on checking with the answer, because the solution is already given there, we have written that. If not, we have to do the second thing also for our justification, whether we are doing the right thing or not while taking the symmetry. So here we are going to discuss the problem on finding vertex of the cone. So here we are not discussing about the concept, I discuss about the procedure in finding vertex of the cone, right? So let us take the problem first. So this is the equation given to me. So I have taken a big equation which represents a cone. So my context here is I have to find the vertex of this cone equation. Now, if you review the steps, what is the procedure behind it? The first thing we have to do is I want to make it homogeneous. So that every term in this equation will have the equal degree. In one way we can understand that we are shifting the origin. We are shifting the vertex of the cone to origin. We think like that. So we are not discussing the concept in depth. The idea here is we are making it as homogeneous by introducing a auxiliary variable. So I will write it as f of x, y, z, t equal to x square minus 2y square plus 3z square minus 4xy plus 5yz minus 6zx plus 8xt minus 19yt minus 2zt minus 20t square equal to 0. Clear? How we have done the homogeneous part? By introducing the auxiliary variable there. Now, the second step is we have to do the partial derivatives for it. The four partial derivatives we are considering it. So here if we consider, it is nothing but 2x minus 4y minus 6z plus 8t. With respect to y, if you perform minus 4y minus 4x plus 5z minus 19t. With respect to z, if you do 6z plus 5y minus 6x minus 2t. And with respect to t, if we perform, it will be 8x minus 19y minus 2z minus 40t. Are you clear with these values? Say. So we are not multiplying the whole equation with t, we are making the equation homogeneous by introducing the auxiliary variable wherever it is required. So this will be minus 6x, right? That is actually we are doing here. I think, yeah, 6 right, right. Fine. The question is, why you are calculating the partial derivatives here? Is that your question? See, if we put t there, in other words, we are shifting the origin. We are shifting the vertex to origin. So, as we have studied one small result that whenever you have a cone with vertex at origin, then it always nothing but a homogeneous equation in any number of variables. 2 variables, 3 variables, 4 variables, anything you can take. So generally, we are going to take x, y, z, which is giving a homogeneous one of degree anything. So to make it homogeneous, the process is described like that. To introduce an auxiliary variable there. And in one way, the idea behind it is, while calculating the partial derivatives, we are having the tangent planes to the cone. Now what happens? The 4 planes, what we have obtained here, will intersect at exactly one point. That point is nothing but the vertex of the cone. So the idea behind it is, we are finding the 4 planes which are tangent, and the intersection of these 4 planes is nothing but the required vertex. So after finding these partial derivatives, we put t is equal to 1 in the same values and we solve them. So by putting t is equal to 1, this is 8, this is minus 19, this is minus 2, this is minus 40. Now we solve these 4 equations. So you will get the value of x, y, z. It is nothing but solving the regular equation. You can do it by simply solving the equations one after the other, or you can write it in the matrix form and you can solve it anything you do. Right? So on solving, you will get the vertex of the cone as 1 minus 2 3. That was the idea. The procedure is given like that. You take a note of the procedure. While solving, you can consider any three of the equations so that you will get x, y, z, and you can observe that the point is satisfying the fourth equation. If so, if you take dou f by dou x, dou f by dou y, and dou f by dou z, if you consider the point of intersection of these three values, then that x, y, z will satisfy the next one. So the idea or procedure is described like that in finding the vertex of cone. So I will give some practice problems for you on this concept. Now we move to the interesting one, that the concept of reciprocal cone. In other words, we can call it as the tangent cone. So in the first class, I hope that I have given some pictures of the reciprocal cone. So here it comes like that. Suppose this is a cone and this is its vertex. Now what happens if you consider a tangent plane to it? Then the normal will become, it will passes through the vertex of the same thing and it will become generated to the other cone. Similarly, if you consider another tangent plane here, its normal, which is passing through the vertex, will become generator. So here you will get the other cone. So this cone we are calling it as the reciprocal cone. So in other way, the set of normals of the tangent planes for a given cone will become the generators of the other cone having the same vertex with the given cone. The new cone, we are calling it as the reciprocal cone. Okay? Is the definition clear? The perpendicular lines, yeah, I will write it. The perpendicular lines to the tangent planes of a given cone through its vertex will yield another cone. Now, does it make sense? So, can you see the picture? Now, if you observe the similarities between these two, if you say this is our given cone and this is the reciprocal cone, we can say that for every tangent plane, one generator will be here. So for every tangent plane for the given cone, you can find one respective generator for the reciprocal cone. The best example is, you can imagine the sand clock. for reciprocal cone visualization, and they both share the common vertex. And obviously, while doing the problems, we take that the vertex is by default origin. So while calculating the reciprocal cone, we are doing the problems with vertex at origin. Okay. Now, how to solve it is, suppose this is our given equation. Now, if you want to find the reciprocal cone of it, then if this is the given cone, the reciprocal cone equation is given by, we use the symbols capital ABC. This is the equation for the reciprocal cone, the formula given by. And the values of the coefficients are determined from the determinant value So if you want to calculate the value of capital A is nothing but the cofactor of small a in this determinant. I mean the matrix, if you can call. Similarly, capital B is nothing but the cofactor of small b. Like that, every symbol is nothing but the cofactor taken in that one. Okay. So this is the formula we use to calculate the reciprocal cone equation. Fine. Please take a note of that. One interesting thing here is, let me say, if our given cone is touching the three coordinate planes xy, yz, zx. These planes are mutually perpendicular. So, for xy plane, z-axis is the normal, so it will become generator for the reciprocal cone. For yz plane, x-axis is the normal, it will become generator for the reciprocal cone. So what happens now, if you say that for the given cone has three mutually perpendicular tangent planes, then for the reciprocal cone you will have three mutually perpendicular generators and vice versa. Clear? So for that there is one small checking condition that, so here if you talk of generators, a plus b plus c must be equal to 0. That is nothing but x square coefficient, y square coefficient and z square coefficient. If you sum up, these must be equal to 0. If you talk of the given cone having three mutually perpendicular tangent planes, it is nothing but BC plus CA plus AB is equal to F square plus G square plus H square. If this condition is satisfied by the given cone, then we say that it will have three mutually perpendicular tangent planes. Okay. Please take a note of that. So let us take the first problem. Here it is. Find the reciprocal cone of (3x square plus 4y square plus 5z square) plus 2yz plus 4zx plus 6xy equal to 0. Now, if you compare the given equation with the standard notation, you will have a is equal to 3, b is equal to 4, c is equal to 5, f is equal to 1, g is equal to 2, h is equal to 3. Accepted? Now let us substitute the values in the determinant. Now, what will be the value of capital A here? If you calculate the cofactor there, is that 19? And for capital B and capital C, you have B is equal to 11 and C is equal to 3. So if you calculate the cofactors H, G, F, you will have the values -13, -5, 3. Therefore, equation of the reciprocal cone is that was the required solution. If anybody has any queries, you can ask. So are you solving simultaneously with me this model? Please tell. Are you with me? Right. So you please check with the values, and that is nothing but the required reciprocal cone equation. Or are you getting any confusion in getting the idea? How we are calculating actually the cofactor? Is it known or not known? To calculate the cofactor, right? Then it will be interesting for you if you do this. Suppose you take the cone equation ax square plus by square plus cz square equal to 0. Ax square plus by square plus cz square equal to 0. Now find its reciprocal cone. Then I say that you are going to get the value as x square by a plus y square by b plus z square by c equal to 0. So if you substitute the values in the matrix a, h, g, everything, so by applying the value, you will get the reciprocal cone equation as like this. You take it as an assignment. Now I take the next model. Can I? Right. show that the general equation of a cone which touches the three coordinate planes is so please take a note of that. The general equation of a cone which touches the three coordinate planes is root fx plus or minus root gy plus or minus root hz equal to 0, where f, g, h are nothing but the parameters. So this question is also based on the reciprocal cone concept. So how it is? Let us say suppose that this is a cone which has three mutually perpendicular generators. In other words, say x-axis, y-axis, z-axis. Then what will be its equation? Can you tell? We have done a problem on this. If we say that if the cone is passing through the three coordinate axes, then what will be its equation? In the beginning, we have done a problem on this. Alright, so it is nothing but fyz plus gzx plus hxy equal to 0. Agreed? Can you remember that equation? Right. So as per the problem, we have to calculate the equation of a cone which is touching the coordinate planes, and the equation will look like as this one. So what happens if you say that this is the cone having the three axes as generators? Its reciprocal cone is nothing but having the three planes or the touching planes or the tangent planes. So this is our target problem. Now what we are doing, I will consider this equation, I will calculate the reciprocal cone of it, then it will come under this category or under this form after doing simplification. So will you get the concept? What is my intention actually in writing that equation? Say. So again, let us compare this equation with the general form. Then what happens if you compare this here? A is equal to 0, B is equal to 0, C is equal to 0. If you calculate H, F, G, they will come the same values as it is. So if you substitute the values in determinant, and you calculate the cofactors as it is, then you will get the reciprocal cone equation as this is the equation of the reciprocal cone. Please check on this if you have a doubt. If the concept is clear for you, then I go with the simplification part. How to convert this form into the required equation model. Root fx plus or minus root gy plus or minus root hz equal to 0. Okay. Please tell, can I proceed further? Yeah. What I am saying is the context of the problem clear to you? Why I am considering the reciprocal cone here? Say, or not clear? Right. Then I will repeat that again. So what is the question tag here? I want to find the equation of a cone which is touching the three coordinate planes xy, yz, zx. And if you find its equation, it will come like this. That was the question tag. Clear? Say yes or no. Right. Now what happens? Apart from straight away finding a cone equation which is touching the three planes, I will draw the picture for your idea. Let me say, this is my cone equation. So the three coordinate planes xy, yz and zx, these three planes are touching this. And the equation of the cone is nothing but this one that we need to prove actually. So apart from straight away taking that a cone which is touched by the planes, I am considering the cone which is passing through the three coordinate axes. Why? Because the similarity between cone and reciprocal cone is nothing but, if you say that xy plane is a tangent plane for this cone, the normal of the xy plane, which is nothing but z axis, is a generator for it, for the reciprocal cone. I already known that the cone which is passing through three axes, its equation is nothing but fyz plus gzx plus hxy equal to 0. So if I calculate its reciprocal cone, obviously it will touch the three coordinate planes. So the underlined idea, I took the cone equation which passing through the axis. The reciprocal cone of it will touched by the coordinate planes. So by taking the cone passing through the axis, comparing the given equation, I have known that what is ABC, FGH values. Using the matrix determinant, I am writing this is the reciprocal cone equation. Fine. Are you getting the outline of it? So we are saying that capital A is equal to 0. So generally the reciprocal cone equation is nothing but capital AX square plus capital BY square plus etc., isn't it? Where A, B, C are nothing but the cofactors. So after finding the cofactors, you will get the resultant equation like this. That is what I am saying actually. I left that part for you. You have to calculate the cofactors. That will come like that. Fine. Simply taking the values from it. So if you substitute the values, let me say, in the determinant, so A, B, C values are 0, say H is H, G is G, so if you consider cofactor of A, it will be minus F square, accepted. If you consider the cofactor of A here, it will be minus F square, agreed. Similarly, you calculate all the remaining cofactors. So for B, if you consider this position cofactor, closing the row and column, it is nothing but minus G square, capital B is equal to. So like that, for everything I am calculating here. So multiplying with minus, this is the required equation of the reciprocal cone. So this cone is touched by the 3 coordinate planes. Now actually, in the problem, the solution is little different. This is the actual equation, but the solution is given like this. So if you do some adjustment in this equation, you can convert this into that model. Is the overall idea clear for everyone? Why we are calculating the reciprocal cone and how we are solving it? Okay. Now let us simplify this part. So my intention here is on doing modification over the reciprocal cone equation. I should be able to convert this into this pattern. So here you take this minus 2fgxy to the right hand side and again add 2fgxy. So it will come as now on the left side part you can write it as fx, then because whenever there is z, you are having a minus symbol. That's why I put minus here. So applying square root on both sides, that you are going to get it. Okay. This is a somewhat different model. However, the simplification part generally not given in the exam point of view, but you should know how to convert it. If at all a question is asked, find the equation of a cone in this pattern, especially if it touches the 3 coordinate planes. So please check on that. Then let us conclude our session here. So we have to discuss one more concept, that is right circular cone, that we will discuss in tomorrow's class. And we have to discuss about the concept of cylinders. It is a very small part, cylinder. That also we will start in tomorrow's session.